Hello and welcome to another video by Kawadri Maths. Today we'll be going over another GCSE Edexcel past paper. And so let's begin with question 1. The question reads, the scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. One of the points is an outlier. Write down the coordinates of this point. Okay, so the outlier is clear. I'm going to label it in red, and that is this one because it doesn't fit the trend that's going on, which is as the number of hours of sunshine increases, the maximum temperature increases. Okay, now it's asking for the coordinates. Okay, so it's between, so if you, you can do a ruler with this. So it's between 9 and 10 exactly, 9 and 11 exactly, so it's 10 there. And it's between, I can just eye it up, it's between 18 and 20, so that's 19. Very easy. Okay, for all the other points, write down the type of correlation. Okay, so the types of correlation you can have are positive, let's write it down here. So, let's just say, okay, so positive, negative, and no correlation. In this case, you can see that as one variable is increasing, the other variable is also increasing. And so you can conclude that it's a positive correlation. Okay, next part of the question. On the same day in another British town, the maximum temperature was 16.4 Celsius. Estimate the number of hours of sunshine in this town on this day. Okay, so given the graph that we have, we're going to try estimate the number of hours of sunshine. So 16.4, if we go back to this graph. Right, so what the mark scheme generally asks for is for you to use a ruler and to draw a line of best fit, which is what I'm going to do here. Okay, I think that's good enough. Okay, always use a ruler, of course. And now we're going to estimate. So the small squares are going up in 0.2s, so that will be 16.2, 16.4. So if I now go to this, okay, and I bring it down. Have I done this correctly? Okay, so what's happened? I seem to have shifted everything. Okay, all right, so if I go down, it's going to be about 13. Now, if you look at the mark scheme, it says, oh, it seems the graph has moved again. Okay, but if you look at the mark scheme, it does give you a bracket. So as long as you're within these two numbers, and the bracket is basically any number between these two, between 12 and 13. So in my case, I can write 13 hours. Okay, now it does say 2 marks here. The first mark being to draw the line of best fit, and the second one is using that line to estimate 13 hours. Okay, the weatherman says temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Yes. So as we said before, as the number of hours of sunshine increases, the maximum temperature increases. So yes, temperatures are higher on days when there's a scatter graph support what the weatherman says. Yes, since there, let's say, there are more, or let's say there are higher temperatures when the number of go back to number of hours of sunshine hours of sunshine are high. Yes, since there are higher temperatures when the number of hours of sunshine are high. You could say higher, yeah, okay. Next question. Express 56 as the product of its prime factors. Okay, now the way you do this is you write down your number, in this case it's 56, and what you do is you break it down into factors, whatever factors that you know, and you stop the branch. A branch stops when the number it ends at is a prime number. So in this case, 56 is made by 8 times 7. Okay, so this branch will stop because there's a prime number here. But 8 can be broken down further into 2 and 4. Now this branch with the 2 at the end of it is also going to end because it ends with a prime number, which is 2. And to make 4, it's 2 times 2. So what you're left with is you multiply these numbers together, and that will be the product of its prime factors. So it will be 2 times 2 times 2 times 7, and that answer is sufficient. So, question 3. Work out 54.6 multiplied by 4.3. Okay, now this is something below, I would call, the standard of Gcse, because it's sort of like your times tables. Okay, now there's two ways of approaching this. One is to, well, there is only one way, which is to multiply normally and then deal with the decimal points afterwards, the decimal point afterwards. Okay, so here you have 3 times 6, that's 18, 4 times 3 is 12, plus 1 is 13, and 3 times 5 is 15, so 1, 6, 3, 8. Then we put a 0 here. 4 times 6 is 24. 4 times 4 is 16, plus 2 is 18. And 4 times 5 is 20, plus 1 is 21. That gives you 8, 7, 14, 3, and 2. And now we decide where we put the decimal point. Since there are two numbers in total before the decimal point, you will place the decimal point 1, 2. You place the decimal point here. So the answer is, if I write it here, 234.78. Now, if you want to have an idea, if you know where you've placed your decimal point is correct, think about it like this. If we were to estimate that as 50 times by 4, that's about 200. So we're roughly close to 234. So that gives us a sort of a sanity check to know that we've placed the decimal point in the right place. Okay, next question, question 4. The area of square ABCD is 10 centimeters squared. Show that x squared plus 6x equals 1. Okay, so obviously the area of a square is the length times by the width, or the length times by itself, because they're the same. So we can write that as x plus 3, which is this length here. This is x plus 3, multiplied by x plus 3, which is this length here as well, x plus 3. and then we expand that bracket, these two brackets, so you get x squared plus, so that's x squared plus 3x plus 3x, which is that and that, plus 9 equals 10. According to this, the area of the square is equal to 10 centimeters squared. Let's write that clearly. Okay, so if we simplify that, x squared plus 6x plus 9 equals 10. Let's subtract 9 from both sides. These two cancel, and this becomes 1. So you have x squared plus 6x equals 1. And that's your answer. So, question 5. This rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kg per meter. Work out the total weight of the metal in the frame. Okay, so the way to approach this question is we need to work out the length of each of the members in the frame, because they've given us a value here which says 1.5 kilograms per meter. So, for example, this edge here would be the weight of this edge would be 1.5 multiplied by 12. But we need to know for the sum of all the pieces of metal. So we know that this is going to be 5 meters because this is also, because the other side is 5 meters, and this is 12. We need to work out what the length of this is. Now, considering it's a right angle triangle, you can use Pythagoras. So if we equate it to, for example, x, we say x squared is equal to 5 squared plus 12 squared. So x equals the square root of 5 squared, which is 25, plus 12 squared, which is 144. Remember, this is a non-calculator paper. 25 plus 144 is 169, which is equal to 13, because 13 squared is 169. Okay, so now if we add up all the lengths, so 12 plus 12 plus 5 plus 5 plus 13, 12 plus 12 is 24, plus 5 plus 5, which is 10, which is 34. 34 plus 3 is 37, so 47. So 47 meters in total is the length of all these straight pieces of metal. Okay, so now what we're going to do is we're going to multiply 1.5 by 47. Another way of looking at it is 1 times 47. Considering we're not using a calculator, the way to look at it is 1 times 47 plus 47 times by 0.5. So that would be 47 plus a half of 47. Well, half of 46 is 23. So this will be 23.5. If we add them together, we should get 70.5 kg. And that's the answer. Okay. Next question. The equation of the line L1 is y equals 3x minus 2. The equation of the line L2 is 3y minus 9x plus 5. Show that these two lines are parallel. Well, we know that for two lines to be parallel, their gradients must be the same. And the way you can see whether the gradients are the same is by referring to the equation of the line in the form of y equals mx plus c, m being the gradient. Okay, now we can already see that equation line 1 is in the form of y equals mx plus c. The gradient is 3. All we now have to show with L2, line L2, is that the gradient of that line is also 3. So what I would do is I would rearrange line 2 into the form y equals mx plus c. So let me take everything that isn't y to the other side. So 3y equals 9x minus 5. I've skipped a step here. I just took everything to the right hand side. Then I divide both sides by 3. I end up with y on its own on the left hand side and 9x over 3 minus 5 over 3, which simplifies to 3x minus 5 over 3. Now, since, or you can say, both lines are parallel because their gradients are both 3. Okay, moving on to question 7. The question states, there are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Okay, so in these types of questions, I always like to state the unknown as x. So let x equal mean mark for boys. Okay, so we know that there are 10 boys. Okay, so let's go over how you would approach this question. They're giving you the mean mark for the class and the mean mark for the girls. We know that the mean mark for the boys and the girls should equal, so the mean of those two should equal to the mean mark of the class, because that's what the mean mark of the class is based on. If you were to say, okay, so the mean mark of class is equal to mean, actually in one way you can say total marks of class equals total marks for girls plus total marks for boys. And this is the basis of our answer. So we know that the total marks of the class is going to be 60, which is the mean mark for the class, multiplied by the number of students in that class. They said there are 10 boys and 20 girls, so we're going to multiply by 30. The total mark for girls is 54, and there are 20 girls. And the total mark for boys is the mean mark, which we've said is x, multiplied by the number of boys, which is 10. Now looking at this equation that we formed, there's only one unknown, so if we rearrange for x, we should get the answer. So this is 1800. So 2 times 54 is 108 plus the 0, and this is 10x. So let's take this to the other side. We get 720 if we subtract 1080 from both sides. That equals to 720 on the left and 10x on the right. Divide both sides by 10, you get 72 equals x. X equals, or you can just write 72 because x is our notation. Okay, write 7.97 times 10 to the minus 6 as an ordinary number. Okay, well, if it's to the minus, it's the same as saying 1 over, since there's to the power of 6, it's going to be 6 zeros. So 1, 2, 3, 4, 5, 6. So 7.97 is going to move, the decimal point is going to move 6 times. So 1, 2, 3, 4, 5, 6. It'll be 0, 0, 0, 0, 0, decimal point 0. So 5 zeros, so 0.000000797. So that's the approach. Just move the decimal point by the number of to the power it is 2. So in this case, if it was 10 to the positive 6, it would move, the decimal point would move to the right 6 times. You would end up with 7,970,000. Okay. Work out the value of 2.52 times 10 to the 5 divided by 4 times 10 to the 3. Okay. Give your answer in standard form. So I'm going to write it as follows, just because I find it comfortable writing it in this form. 10 to the minus 3. Again, we can write that as 2.52 times 10 to the 5, 4 divided by 10 to the 3, because that's the same as but if I write it like this, 4 times by 1 over 1,000, which is the same as multiplying if you're going to divide the bottom by 1,000, it's the same as multiplying the top by 1,000. So that will be 2.52 times 10 to the 5 times 10 to the 3 over 4. So if we bring that here, you have 2.52 times 10 to the 8 over 4. If this part here doesn't make sense, I will go over it after this question. And then it's 2.52 divided by 4. So, okay, so 252, half of that is 126. So half of that is 63. So it will be 0.63 times 10 to the 8. Now they want it in standard form. Standard form has to be in between 1 and 10, not including 10. Let's say 9.99999. So we have to borrow a 10 from here, or take a 10 and give it to the 0.63. So it becomes 6.3. And now because we took a 10 from 10 to the 8, becomes 10 to the 7. Okay, now a bit about what just happened here. Let's make some space. Oh, where should I do it? Let's do it here. If you have something of this form, where you have one fraction being divided by another fraction. In this case, we had, let's see what takes up this point. Okay, so 2.52 times 10 to the 5. And this, in this case, is 1. This number in this case is 4. in this case is 1000. The rule is that if you have something like this going on, you can multiply this number by this and this number by this. This goes back to the whole idea of, if I were to write it as, so 2.52 times 10 to the 5 over 1 divided by 4 over 1000 is the same as 2.52 times 10 to the 5 over 1 multiplied by 1000 over 4. That's just the rule. Okay, so the answer is 6.3 times 10 to the 7. So question 9 states, Jules buys a washing machine, 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT added? Okay, so the way to approach this question is we can say let X equal the original price, and then what we will say is X multiplied by some number should give us £600. Now, since it's a 20% increase to the price, it's one way of writing it is 120%. So X multiplied by 120%, because it's the 100% being the actual price of that product plus 20% on top, so 120%. Now we can write 120% as a decimal. That'll be X multiplied by 1.2 equals 600. And then X equals 600 divided by 1.2. This is the same as 6,000 divided by 12. Now we know that 12 goes into 60 5 times. So 5 plus the 2 zeros gives you 500. So the original price is £500. Okay. If that wasn't clear what I did, I basically did 60 divided by 12 again, which gives me 5, and then I add the 2 zeros onto the end. Okay. Whichever way comfortable you could do longer division, but remember this is a non-calculator paper, so you will be expected to know how to do it without using a calculator. Okay. Show that, so question 10, show that x plus 1 multiplied by x plus 2 multiplied by x plus 3 can be written in the form of ax cubed plus bx squared plus cx plus d, where a, b, c, and d are positive integers. Okay, so the way, I mean there's many ways of doing this again. The approach I will take is let's multiply the two last brackets. Reason being is because I want to be able to multiply bigger numbers by 1. So, but again, there's more than one way of doing this. So x squared plus 2x plus 3x. I'm not doing anything special here, just expanding these two, multiplying these two brackets, plus 6. And then I'm going to do x squared plus 2x. Oh, well, I can simplify that as 5x plus 6 multiplied by x plus 1. Okay, so I end up with x cubed plus 5x squared plus 6x plus x squared plus 5x plus 6. If I simplify that, I end up with x cubed plus 6x squared plus 11x plus 6. And that's the expansion. Very straightforward. Again, if anyone has any questions, feel free to leave a question in the comment section below, and I'll hopefully answer any questions you have. So question 11 is stating the graph of y equals f of x, i.e. y equals a function of x, is drawn on the grid. Now, according to this question, we're not interested in actually what f of x, the function of x represents. The graph is sufficient for us. Write down the coordinates of the turning point of the graph. Well, we can see the turning point of the graph is this point here, because it's sort of, it's pretty straightforward. It's turning there. It's where the gradient is 0. Write down the coordinates of the turning point. So we'll start off with the x-axis, which is 1, and the y-coordinate, which is -3. Okay, write down estimates for the root of the function of x, in this case, this graph, this sketch, equal to 0. Okay, notice how it says roots, meaning that we're expecting more than one number. Now, what this means is, it's asking, when does this graph equal 0? And for those points where it equals 0, what are the x coordinates? So when it says roots, it usually means the x coordinates. So this function of x equals to 0 when it crosses the x-axis, right? Because that's when, if you think about it, it's when y equals 0. The line y equals 0. So any point along this line, y equals 0. And you can see that because, for example, this coordinate here would be 1, 0, 2, 0, 3, 0, 4, 0, and so on. That's the coordinate. So the y coordinate is always going to be 0. Okay, and this one, just for the sake of further clarification, so this will be y equals 1, this line, and so on and so forth. Anyway, so it crosses the x-axis, which happens to be y equals 0, at 2 points, and they're asking for estimates. Now again, we don't have to get these exact, but we will try. I'm going to just rub out what I have done, just so I can see clearly. Okay, so I can see here that each cube represents 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So it's between 0.7 and 0.8. We can go with 0.75. So minus 0.75. And we can go here with, so this is 2.5 here. So this is 2.5, then 2.6, 2.7, again, so 2.75. So it's between 7.7 and 0.8. Okay. Use the graph to find an estimate for f 1.5. So in this case, they're saying, well, what does y equal when I plug in 1.5 for x? That's literally what it's asking here. What is, when x is 1.5, what is y? That's the question. And notice there's only one answer. That's because 1.5 is here, and it crosses literally there. And you can see on the y-axis is that each cube actually represents 0.2 now. So minus 2.2, minus 2.4, minus 2.6, minus 2.8. So the answer is 2.8. So always minus 2.8. Make sure you're always aware that the axes might not always be to the same scale. For instance, horizontally, the width of each square, small square, is 0.1, whereas vertically it's 0.2. Okay. Okay, so question 12 asks us to find the value of 81 to the power of a half. Okay, so how do we approach this? First of all, in terms of indice rules, what does the negative sign mean practically in this situation, and what does the half mean? Let's deal with the negative sign first. 81 to the power of minus a half. The minus is the same as the reciprocal of that number to the power of the number, the indice. In this case, it's a half. Okay, and then the half is square root. So anything to the power of a half is the same as square rooting that number, in which case it's 1/9. Okay, find the value of 64/125 to the power of 2/3. Okay, now the way you can simplify this or break it down is this left hand side is the same as what I'm going to write on the right hand side, which is as follows: 64/125 to the power of 2 to the power of 1/3. And you'll see why I've written it in this way, but these are indice rules. 2/3 can be broken down into this, because if you have a number to the power of something and then that number to the power of something else, you can multiply those two indices, those two powers, by each other. But I like to separate it, and here is why. It's because I'm going to now square the top and the bottom because it's being squared, and then I'm going to, now since a half or 1/2 was square root, 1/3 would be cube root. So let's see how that goes. In fact, we can actually write it as 64/125 to the power of 1/3 and then square it. So you can do both ways. I'm going to choose the latter way because it's easier to cube root 64 than it is to square it. In this case, 64 cube rooted is 4, because 4 times 4 is 16, and 4 times 16 is 64. So that's 4, and this is 125. Well, knowing our cube roots, this is why it's good practice to know what your cube roots are. 5 cube rooted, 5 cubed is 125. 5 times 5 is 25. 5 times 25 is 125. So you end up with 4/5. Now I can write it as that, because we have said that this is equal to what's in the bracket here. And now we're going to square it, which in this case is going to be 16/25. Okay, question 13. The table shows a set of values for x and y. Y is inversely proportional to the square of x. Find an equation for y in terms of x. So y is inversely proportional to the square of x. So y is inversely proportional to the square of x. That's how you translate that sentence to there. If it said it was directly proportional, it would just be y is directly or is proportional to x squared. But because it says inversely proportional, we'll put it at the in fraction form and put it as the denominator. So it will be the reciprocal. Whenever it's inversely, it means it's the reciprocal. It's 1 over that. So if it said y is inversely proportional to the cube of x, it will be 1 over x cubed. Okay, this can be translated as to y equals some constant multiplied by 1 over x squared, which we can write as k over x squared. Right, so we're left with y equals k over x squared. Now, seeing as they've provided us with different sets of x and y values that satisfy this equation, we can actually plug in numbers to work out what k is. So they say here that when x equals 1, y equals 9. So 9 equals k over 1 squared. Hence, k equals 9. Because 9 times 1 squared, well, 1 squared is 1, multiplied by 9 is 9. So k equals 9. So we can actually write the formula here. Y equals 9 over k squared. Okay, and then it says find the positive value of x when y equals 16. Okay, so 16, so let's plug in 16, let's plug in 16 for y, equals 9 over x squared. Sorry, did I write k squared? It should be x squared. Okay, let's rearrange this. So we get 16x squared equals 9. X squared equals 9 over 16. Then I'm going to square root both sides. Now I should get plus or minus the square root of this, but because they're only interested in the positive value, I only need to show the positive one, which would be root 9 over 16, which is 3 over 4.